Alright, let's take a look at part 3, which is Newton's second law. This says that the acceleration of an object is both directly proportional to the force applied and inversely proportional to the mass of the object. So we're just combining the two things that we just looked at in part 1 and part 2. So to put this into mathematical language, I'm going to do the equation here in red. The acceleration of an object. For that we can use the symbol A, and then is, we can use the equal sign for is, directly proportional to the force, so that's going to be force, and inversely proportional to the mass. That means mass has to be on the bottom, just like when we had y equals 1 over x. So looking at units for this, the units for acceleration is meters per second squared. The units for force is newtons, and the unit for mass is kilograms. This equation can also be written another way. If we multiply both sides by mass, then we get the masses canceling out on the right side, and we get F equals M times A. If we look at the units this way, we'll see that we have newtons for force equals kilograms per mass times meters per second squared for acceleration. So a newton can actually be defined, and if we put 3 lines, that means defined as a kilogram times meter per second squared. Okay. Now, take a look at the examples here. The acceleration of a Tesla is 10 meters per second. What would be the new acceleration if the engine force is tripled and the mass of the car is doubled? So if we go back to our equation, that acceleration equals force divided by mass. And I'm going to use blue here to show the changes that we're looking at. So we're showing that the force is tripled. And if we're going to triple on top on one side, it means we have to triple on the other side. And we know from before that 3 times the force will give 3 times the acceleration. Now we're just seeing this in another way, in a mathematical way. And that's from here. Force is tripled. I'm going to use a different color here. I'll use green. I'll use something else that's brighter. Let's do purple. If the mass is doubled, we can show that by putting a 2 in front of the mass. And that means we have a 2 down here. And because this is force divided by mass, we have 3 divided by 2. So what we have going on here is, like algebra, whatever you do to one side of the equation, you have to do to the other. So we divided by 2 on the right side, we divided by 2 on the left side. So now we have 3 over 2, and if we multiply 3 over 2 by the original value for the acceleration, we're told here that the acceleration is 10 meters per second. Then we have, that becomes 3 times 10, which is 30, divided by 2, which is 15 meters per second, or we can write it meters per second squared. So that would be the new acceleration. Now we have the answer. So part B, the acceleration of a Tesla is 10 meters per second, same thing. What would be the new acceleration if the engine force is doubled and the mass of the car is tripled? Alright, so let's go through this methodically. The force is doubled, and the mass of the car is tripled. We start with our original equation, that acceleration equals force divided by mass. And we are going to be doubling the force and tripling the mass. So when we double the force on one side, that means we will get double the acceleration on the other side. If we're tripling the mass on one side, we will get 1/3 the acceleration on the other side. And notice again, I'm just taking what was an equation, a equals f over m, and I just multiplied both sides by 2 over 3. And now we can say that the new acceleration will be, so here, what would be the new acceleration? Question mark. Now the new acceleration will be 2/3 times the old acceleration of 10 meters per second per second. And now that's going to be 20 divided by 3. Oh, Mr. Gettler, you picked hard numbers. 20 divided by 3, well, you could use a calculator. 6.66, if I'm not mistaken, repeating, meters per second squared. How about part C? The acceleration of a Tesla is 10 meters per second per second. What would be the new acceleration if the engine force is tripled and the mass of the car is halved? Alright, so I'll let you, you can pause and kind of work ahead of me. I'm going to keep going, but I encourage you to pause and see if you can do it on your own. Force is tripled, mass of the car is halved. The original equation was a equals f over m. But I'm going to show that the force is being tripled, so whatever it was is now 3 times bigger. The force is, the mass of the car is now halved, so by half, we can put this as 1 over 2. And I'll show you in a moment that there's another way we could do that. So this becomes 3 over 1 over 1/2. And now we have a little bit of trickier math here. 3 over 1 over 2 times the original value of 10. Okay, so as I was saying before, rather than dividing by 1/2, we can multiply by the reciprocal. So let's just take this one divided by 1/2. Let's move it up here and do multiply times 2 over 1 instead. So now this part here becomes 3 times 10 times 2, which is 3 times 10 is 30, times 2 is 60. So that would be 60 meters per second square, which is the new acceleration. So what would be the new acceleration? Yeah, so just to be clear here, line the whole sentence there. Okay, now I said that there's another way we can think about this, and there is. Rather than putting in 0 or 1 over 2, we could have also instead used 0.5. 0.5. And now we would have just gotten 3 divided by 0.5 times 10. And, on a calculator you could just do 3 divided by 0.5 times 10, and if the laws of math haven't changed, you'll still get 60. That's the answer. Okay. Thank you again for tuning in.